Hi everyone, in this particular video we're going to learn about salting in and salting out. So salting in and salting out is a very important phenomena in terms of protein solubility. So we have to learn, when we put a protein in an aqueous solution, when we put a protein in an aqueous solution, and then we put some salt in it, right? So it could be any salt. So if I put sodium chloride, then how is this particular protein going to react? That means if I put high concentration of salt in this particular aqueous solution, and then if I put a low amount of salt in this particular aqueous solution, how is this particular protein going to react? So we're going to learn about that in salting in and salting out. So that was just a small general introduction. Now we're going to go into more deeper knowledge. So let us talk about salting in. So I'm going to be very specific. So out here, we're going to talk about solute. That is our protein. You know what is a solute, right? Solute is something that gets dissolved in the solvent. And then in terms of solvent, we are taking H2O, that is simple water. So, and then we also have salt. Okay, so these are the three things that we have to understand. So solute, that is protein, solvent will be water, and then we'll add the concentration of salt or decrease the concentration of salt. So we'll see upon that. Okay, so salting in is a phenomena where we put a small amount of salt in this particular solution, right? So this is the blue one is the protein, and then there is water in it. So it is actually inside the water. Okay, so we have just dissolved it in water. So now the protein, at first what will happen is, let me just draw this proteins. When I first dissolve in the water, the proteins are very close to one another. They are very close to one another, and they have this electrostatic force around them. So let me just write it over here that they're gonna have. So okay, so they're gonna have electrostatic interaction, right? So electrostatic attraction or interaction, whatever. So this, all these four proteins are going to have electrostatic attraction with one another. Okay, now when they are just introduced in the water, it's very hard for like the protein to actually get and then make bonds with the water, right? It's not that it cannot make bonds with the water. Definitely these proteins can make bonds with like the water molecules, because the hydrophilic sites are exposed at the surface of the proteins, right? So it is possible that they definitely can make bonds with water as well. But in terms of their own attraction, in terms of this whole protein molecule which is like still interacting with one another, they have an electrostatic attraction between them. And then it's very important that when we put the salt in a very low concentration, so very low concentration, when we put the salt, what will happen is this electrostatic attraction will get disrupted. When it gets disrupted, what will happen is the protein molecules, the protein like the polypeptide chain will separate from one another. So I'll just try to show you. So at first they are conjoined with one another, right? Now they have just a moment, I'll not do this, rather I'll just do this. So I'm just rubbing this electrostatic force. to show you that afterwards what will happen. So the proteins are going to go away from one another, as you can see, right? So at first they were like together, so they were together. Now after the electrostatic forces has been disrupted, they have gone away from the from each other. Now, as I told you that the salt board will be surrounding the proteins, right? So when this particular salt molecules are surrounding the proteins, they cannot aggregate with one another. Since they cannot aggregate with one another, they will form bonds with the salts and also with the water. So I'm just, the red one is the, what do you say, the salt. Okay, so I have shown out here red, that is the salt. So if I take an example of a salt, that is, if I take sodium chloride, right? So whenever I take this salt is NaCl. This is going to break into Na plus and then Cl minus, right? So the Na plus will, whenever it gets dissociated in this aqueous water molecule, what will happen is, the particular, for example, this protein has a positive charge over here, right, and a negative charge over here. Then there is a possibility that the chloride ions can come over here, right, because chloride has a negative charge, and then this will get attracted to the positive charge present in the protein. Now why do you think I'm saying that a protein can have both positive and a negative charge? Because a protein consists of amino acids, right? And amino acids in their R group can have any kind of like R group. For example, they can have a group that can produce a negative charge, or they can have an R group that can produce a positive charge. So there are many possibilities, and then there are many amino acids which have positive charge and many amino acids which have a negative charge, right? So the Cl minus will come and bind with this positive charged one, and the Na plus will come and bind with this particular minus or negative charged protein surface, right? So as you can see over here, that when I added a very less amount of salt, what is happening is that the salt gets dissociated, right? And then it becomes Na plus and then Cl minus, right? And then afterwards what will happen is, this protein can have either a positive charge or a negative charge, and I'm talking about all the proteins. Okay, I'm taking consideration of all the proteins over here. So it can have either a positive charge or a negative charge, and whenever the salt breaks, there will be one positive and then one negative, right? And then the positive charge goes and bind with the negative one, and the negative one goes and binds with the positive one, right? So out here what is happening is, I can see that the protein has disrupted the electrostatic force between them. So let me just write electrostatic force as well, so that you don't forget. So I'll just write over here disrupted electrostatic. I'm just going to write electrostatic force, right? So as you can see over here, that the protein has not aggregated, and it is making sure that it is getting away from the away from one another, so it is not aggregating. Now another case is that in this particular thing only, what will happen is, since the protein is not aggregating, it is away, and then it is also forming certain bonds with Na plus and then Cl minus. Now there is a possibility that the protein can also form bonds with water. So let me just write it down here. I'm going to remove this salt, because this looks like a very high salt concentration, which is actually not there. So I'm just going to rub it, and then I'm just going to show it over here, that H2O. So proteins can now form bonds with the water, right? So now what is happening is that at first the sodium got dissociated, proteins aggregated were disrupted electrostatic force, and then the salt forms bond with the positive and negative charge of the protein molecules, and then suddenly the protein also starts to form bonds with the water molecules, right? So as you can see over here, that the solubility is actually increasing, right? The solubility is increasing. And then why do you think the solubility is increasing? Why do you think the solubility is increasing? Because the protein are not aggregating with one another. Now they have started to form bonds with hydrogen, so they are actually solubilized more in the water, we can say that, right? So out here also I was going to show you the same thing. I've just shown out here that positive and negative charge, and then the positive and the negative can interact with the salt ions, and then it can form bonds with the water molecules. So I'll just write it down here that it is forming nice bonds with water. Okay, so H2O and then nice bonds with water. Okay, now you must understand that what exactly salting in means, right? So salting in means to put less amount of salt, right? And then which will increase the solubility of the proteins, right? And another thing is that a charge, yes, this one is also done. So we have to understand the concept of salting in by understanding how much concentration is actually required for a salting in phenomena. So 0.15 molar is actually the concentration where the salting in takes place. That means until and unless this point is reached, the phenomena of salting in will carry out. That means the proteins will dissolve properly in the water. But as soon as the uh, concentration of the salt increases from this particular value, then what will happen is another phenomena, that is salting out, will take place. Okay, so salting out will take place. So this is the salting out. So now let us try to understand what exactly is salting out, right? So as you can see over here that okay, so in salting in, what will happen is we will put more amount of salt, right? So if suppose if I put a heavy amount of salt, or let's say just 0.15, right? So uh, just a moment. Okay, so if I put like a large amount of salt, right? So now what will happen is the salt molecules will start to form, like it will start to first it will start to surround the proteins, right? So definitely we know that the protein has a positive charge, right? A negative charge, a positive charge, negative charge, positive charge. So now these salts are interacting with the protein at first, but and as you can see over here that every protein is actually surrounded by a salt, right? And then this is uh, until the salt surpasses the value of 0.1 molar. So now what will happen is the salt ions, when they have reached a particular surpassed a particular point, they're going to be very much high in the water, right? So when they are very much high in the water, what will happen is the NaCl, right, plus H2O, right? So we already know that the NaCl plus and then Na plus and Cl minus goes and bind with the proteins positive and negative charge, but we have not talked in terms of like water, right? So when it goes and binds with the water, now what will happen is they will try to form sodium hydroxide and then HCl, right? So Now they will try to, the sodium chloride will try to compete with the proteins, right? It will try to compete with the proteins for the water, because at first what was happening, the salt was low in concentration, and then therefore when it was low in concentration, it is not competing with the proteins for the water, right? It is not competing with anything. It is just surrounding the proteins, and then after surrounding, the protein aggregation is getting disrupted, and then they are forming nice bonds with the water, right? But out here, when the salt concentration is increasing, after 0.15 molar, now what is happening is the salt molecules are competing with proteins for the, as you can see over here, the salt molecules are competing with proteins for water. Now what will happen is, you know uh, all these proteins, all these proteins which are surrounded by salt will now like leave the proteins. As you can see over here, that I'll just rub it, okay, and then I'll show you. For example, so I'm just rubbing it. So I'm just gonna show you. So let's just take another one. So let us take this one, and then, oh, this one, this one over here as well, this one over here as well. So I'm just gonna rub all of it so it becomes more clear. So all the salt molecules are, every salt molecule will not go like it. I'm just like trying to show you that most of the salt molecules will leave the protein, right? So I've just kept it one over here. So now the interaction with the protein has decreased, right? Now what is happening is, this particular is actually forming bond with the water molecule. So I'm just going to draw water over here, right? So I'm just going to show that they're going to bind with one another, right? So the salt is now, the salt, this is the blue one is the water, right? So this is the water, and then the water is this is the water is forming bonds with the salt now. And then instead of like these proteins interacting with the water, now the salt is competing with the proteins to interact with the water. And yes, the like the salt is successful in actually making it possible. And then now what will happen is, I've drawn it over here. So as you can see over here, that all the salt molecules, the red one is the salt actually, so the red one is actually interacting with blue ones, right? Now the protein has after a certain point of time, the protein gets dehydrated, right? Because every water molecule is attracted to the salt ions, and then when the protein gets dehydrated, what will happen is, let me write rehydrated protein over here. I'm just going to write it over here. So every protein, when it gets dehydrated, the hydrophobic spots, that means we all know that the protein is actually having a hydrophilic surface and then a hydrophobic core part, right? So when there is no water, the water, there is water, but the water is like getting interacting with the salt, right? So the protein is actually does not have any kind of water molecule to interact with. So the hydrophobic spots, that is like the core spots, will get exposed now. So we can say that these are exposed hydrophobic spots. So when hydrophobic spots gets exposed, now what will happen is, these two proteins will now start the proteins start to aggregate with one another, because we all know that hydrophobic interaction will take place, right? So this will interact with one another, this, and then together these hydrophobic spots will allow the proteins to aggregate with one another, and finally when it aggregates, a precipitation is formed. So I can see that this is actually a precipitation, right? So what was the phenomena in salting out? Simple phenomena: when the salt concentration was more than 0.15 molar, the salt molecules will start to form bonds with water, right? And then slowly it will leave the protein, and then when it leaves the protein will feel dehydrated, right? But it's not that all the salt molecules will leave the protein. Definitely, like there are certain points where there is presence of salt, and then you know what will happen is, after that the hydrophobic spots will get exposed, and then after exposure, a precipitation is formed. And then after this, what will happen now is, uh, the phenomena of salting out will take place, right? Another thing is that, whenever we talk about salting out, whenever we talk about salting in and salting out, why do you think this process is very important? Because why are we talking about protein solubility and all these things, is because whenever someone wants to take out the protein, if they want to extract the protein, and then they want to do some research, what will happen is they will try out the phenomena of salting in and salting out. So salting, whenever if you want to extract protein, you cannot directly add a large amount of salt, and then you cannot just add salt and then you will think that the protein will precipitate. The salting out phenomena is always supported by salting in. That means we have to follow first salting in, then only salting out phenomena could take place. Okay, so I hope you're clear about salting in and salting out. This is a common phenomena in terms of protein solubility. Thank you so much for watching. If you like this video, please like, share and subscribe. Thank you so much.